We have a fun lesson for you here today. It's about sinusoidal application problems. Now what we're going to do is we're going to take all that trigonometry stuff we've been doing for the past couple of days and we're going to apply it to one problem where you're going to be answering all kinds of questions. You're going to be sketching a graph, you're going to be writing an equation, you're going to be using the equation to solve and substitute to find values. We've got a lot of stuff coming here. So, first thing I say you should do is read the problem once and then read it again to pick out all of your important information. Important information you are going to need to find somehow is your frequency. You're going to need your period. You're also going to need to know your important graph information like your crest, your node, and your trough, which is going to require your amplitude. So you're also going to need to know your amplitude. And then you also need to know your start and your stop. So you have a lot of information to find, so that's why I always say read it once, then read it again. So go ahead and read this question on your own first, and then we will talk about all the important information you need. So pause it, read it, and then we'll do it together. So, we're going to suppose that the water wheel shown rotates at 6 revolutions per minute. You just found your frequency. So you got 6 RPMs, which means in a minute we know there are 60 seconds. And if we have 60 seconds for it to rotate 6 times, one rotation will only take you 10 seconds, which is your period. Your period is the length it takes for one rotation. So we have our crest, node, and trough we need to find. Let's look at the diagram. We know that the radius is 7 feet, but the center of this wheel is only 6 feet above the water. So that means there is an additional 1 foot below the surface that this wheel is going to go. So since it's 1 foot below the water, we know our trough is going to be -1. So if we think about that, we know the diameter of this wheel is 14. So that means our crest is at 13. So now to find the node, you could just average those two. 13 plus a -1 divided by 2 is 6. Or we could just remember that this is already 6 feet above the water. So our node is 6. So then you just need to say, what is your amplitude? That comes from your radius again. That'll bring you to the top of the wheel, which is 7 feet above 6, and 7 below, which brings you to your -1. So your amplitude is 7. So we have all the good stuff here for our heights and our frequency and period. The last thing we need to do is find our start and stop. So you read again, and what you need is you need to find a time where this is at its crest, node, or trough. So it says 2 seconds after you start your stopwatch, point P is at its greatest height. So we are going to start 2 seconds after the stopwatch is clicked. So that means we're going to have this and we're going to stop at 12 seconds because we know it takes 10 seconds for it to repeat itself. Now we just have to find what's happening in the middle. So remember, this is just like writing the equation. So we need to get this first number to be 0. So we need to subtract 2 from every side. So that's going to give us 0 is less than or equal to t minus 2, which is less than or equal to 10. And now we need to turn this 10 into a 2 pi. So what can we multiply 10 by to make it 2 pi? Well, to turn a 10 into a 2, we need to divide by 5. And we need to take a 2 and multiply it by a pi. So you need to multiply everything by pi over 5. So that's going to give you 0 is less than or equal to pi over 5 times t minus 2, which is less than or equal to your 2 pi. So now you have everything you need to graph and write the equation of this sinusoid. So let's start. Let's start with the sketch first. So Here we go. Stretch it out. We know that we have 2 seconds for our start and 12 seconds for our finish. And of course, there's going to be 3 tick marks in between. Now, you can remember to find your interval, you just divide your period of 10 by 4, and your interval is going to be 2.5. So that's going to give you 4.5, 7, 9.5, and then of course add 2.5 more, and it brings you all the way to 12. We have a crest of 13, a node of 6, and we have our trough of a -1. So from here, if we wanted to sketch the graph, we have our crest, trough, node. We have our start and finish. And since this is starting at the highest point, we're starting up top, and then we just follow the pattern. Node, trough, node, crest. And here we go. That is the sketch of our graph. Easy once you have all the information. I mean, all you have to do is write it all out, and that part should be pretty simple. So now we have to go write the equation. So a couple things to keep in mind here. Where are you starting? This graph started up top. So the first thing you should say to yourself is this is going to be a cosine graph. And we also have d, because it did say which variables to use, so d is your distance, is equal to, now the first number we need before our cosine is our amplitude, which we found is 7. We found a start and stop, so that gave us our pi over 5 with our t minus 2. And then we know that this node is 6 feet above the water. Again, once you have all the information, it's pretty simple to do. So now we're just going to answer 3 more questions about this water wheel. So first of all, what does d of -0.5 mean? Well, if you think about that, negative has to mean it's under the water. And 0.5, since this is in feet, basically means that it is 0.5 feet or 6 inches below the water. That's what it means. So how many times in 1 minute will the wheel have a distance of 6 inches below the water? So to figure that out, you can do it graphically on your graphing calculator if you would like, or you can just think about it this way. If we were to go back to our graph and look at the graph, and then just sketch a little line at -0.5. 1, 2. It's going to hit 6 inches below the water twice, because think about it, it's going to hit -6 inches as the wheel's going down, then it's going to reach its minimum of 1 foot below the water, and then on its way back up, it's going to hit -6 inches again. So, to answer that question, if this thing rotates 6 times per minute, then this is going to happen 2 times per 10 seconds, which is going to happen 6 times in a minute, which is 12 times. That's just another way you can think about it. Or you can use the graphing calculator to kind of get an idea, but then you'd have to stretch it out for a total of 6 cycles. I'd rather you just think about it. So, last thing is we have to predict the distance from the water when time is 5.5, 15.5, and 0. Of course, those are all in seconds. So, all you need now is your graphing calculator. For this, all you have to do is type your equation into the calculator and just use your table or your ask feature. So if you substitute 5.5 into your calculator, you're going to have 1.886 feet. If you substitute 15.5 seconds, again, that's going to give you 1.886 feet. And if you substitute 0, that's going to give you 8.163 feet. So when you first watched this water wheel, you said that it was 2 seconds before it reached the top. That means while you were first starting your stopwatch, this was 8.163 feet above the water. So that's it. That's how you use an application problem to write an equation, sketch a graph, and answer some questions about it. So for this video, we are done. I'm sure you noticed there is another example, and we are going to save that for class tomorrow. If you would like to try it on your own before you get there, that's fine. But for this video, we are done, and we'll do the next one together, or you can try it on your own. It's up to you. This is Longo, and I'm out. See you, bye.